Hello everyone, myself Venkatasai Talupalli, an intern at Emertxe Information Technologies, will be presenting my project that I've implemented during this internship, that is Car Black Box. So let me start by the topics that I've learned during this internship, beginning with the fundamentals of C programming, loops, pointers, arrays, storage classes, and many more. I have learned what an embedded system is, what are the types of embedded systems and applications. I have learned more about the microcontrollers. I've also learned how to work on MPLAB IDE, X8 compiler, PixSimLab simulator tool, in which I have implemented this project. Now, let me first give a brief overview of the project. Car Black Box. A car black box is a device installed in the vehicles which monitors or records events such as speeds, braking, mileage, location, and many more. It provides all the records of all events prior to vehicle crash. This is a device which is either physically installed in our cars or downloaded as a smartphone app. These are the major requirements to implement this project, namely MPLAB IDE, PixSimLab, X8 compiler, the microcontroller, PIC16F877A, and the various peripherals which I'll be discussing in the coming slides. So, embedded system. Any combination of hardware and software which is intended to do a specific task can be called as an embedded systems. There are few types of embedded systems, mainly standalone, real-time, networked, and mobile. A microcontroller can be defined as an integrated circuit which is capable of being programmed to perform a specific task. A general microcontroller consists of the processor, the memory unit, serial ports, peripherals such as timers and counters, and many more. The microcontroller which I have used in this project is PIC16F877A. Moving on to the interfacing of the microcontroller, PIC16F877A consists of 5 input-output ports, namely port A, B, C, D, and E, and 3 timers, timer 0, timer 1, and timer 2. There are various peripherals that can be interfaced with the microcontrollers. To name a few, we have LEDs, buzzer, digital keypad, matrix keypad, SSDs, CLCDs, EEPROM, and many more. So the first and the major peripheral of this project is CLCD, known as Character Liquid Crystal Display. And there are two types of CLCDs that are available in the PIXM lab, that are 16:2 and 16:4 displays. In this project, I have used 16:2 display. Switches. It provides simple interface and it comes in different shapes and sizes, and it is mainly preferred when the number of user inputs are less. Some common applications of these tactile keys are mechanical keyboards, computer mouse, and our mobile phones. Interrupts. An interrupt is a communication process set up in a microprocessor or a microcontroller in which an internal or external device requests the MPU to stop the processing. Then, the MPU acknowledges the request and attends to the request. Then it goes back to the processing where it was interrupted. ISR, or known as interrupt service routine, attends to the request of an interrupting source. When an interrupt occurs, the MPU completes the instruction being executed and disables the global interrupt enable. It stores the address from the program counter in the stack, and the ISR must be terminated with the instruction RETFIE. When RETFIE instruction gets executed, it returns from the interrupt. One of the major peripherals of this project that is timers. A timer is a specialized type of clock which is used to measure time intervals. It counts down from a specified time interval and is mainly used to generate a time delay. Some specific terms related to timers are resolution refers to register width such as 8-bit, 16-bit, etc. Tick, which refers to up count or down count. Quantum, it is a measure of time which is responsible for the tick. Scaling, which can either be pre-scalar or post-scalar. Now let's move on to the project implementation. This is the interface of the NPLab IDE, and this is the project which I've created. The source files and the main.c file in which the main program is written, and we have included the main.h file in which all the header files of the peripherals is been included. Now let's just load this hex file onto the Pixum lab and see the simulation. I load this hex file. So this is the dashboard screen of the car black box device in which the current time, current event, and the current speed is displayed. Using this potentiometer P1, we can vary the speed down from 0 to 99. And every gear shift is considered as an event which has to be recorded. Using switch 2 and switch 3, we can shift the gears. So when I click on switch 2, the gear is shifted to neutral gear, reverse, gear 1, gear 2, and when I click on switch 3, it shifts to gear 1. So then again, when I press on switch 2, so gear 2, gear 3, and the switch 1 is dedicated for the collision event. So when I click on switch 1, so the event is being updated to collision event. Now to view the logs or events, a password based system is built. So whoever wants to view these logs needs to enter the password. To enter the password, the user can either press switch 4 or 5. So when I press on switch 4, it asks me to enter the password, and it waits for a time interval of 5 seconds. After 5 seconds, it returns back to the dashboard screen. So, and when I click some random password, so it's being displayed as I've entered the wrong password and 2 attempts are remaining. And when a user runs out of all the attempts, the user will be blocked for 60 seconds. So now when I enter the right password, the user gets access to various options such as view log, clear log, and to change password. To view the logs or to select this view log option, switch 6 is being used. So when I click on switch 6, so view log is selected, and these are the logs which I have recorded. Yeah. Now when I get back to the dashboard screen, yeah, these are all the events. When I get back to dashboard screen, now again if I record some random events, collision, yeah. Now when I enter the right password, now again we'll get the various options. Now to clear the logs which we have recorded, we can scroll down using switch 5 or switch 4 pins, and scroll down, switch 5 is used, and we'll select this option using switch 6. So when I click on clear logs, it's being displayed as logs cleared successfully. Now when I try to view the logs, when I click on switch 6, so the events are not being showed and no logs message is displayed. This is the dashboard when I get back dashboard screen. Yeah. So this was all about my internship project, Car Black Box. This brings to the end of my presentation. Thanks for watching.